So today we'll talk about 4.5, the graph of rational functions. So today we'll talk about the situations with no holes in the graph. And on Wednesday, we'll talk about the situations with holes in your graph. Okay, so first let's look at this problem. R of x equals x plus 1 over x times x plus 4. Okay. So before we graph, I want to gather some information like X-Intercept, Y-Intercept, all the asymptotes, and so on. So beginning from X-Intercept. So to find X-Intercept, we want to make y equal to 0, right? So in this case, this whole thing equals to 0, that's y. So if the whole thing equals 0, if this fraction equals 0, if and only if the top is equal to 0. So basically, when you find X-intercept for a rational function, you only look at the top. All right. So we have one X-intercept, which is -1. So here we have X-intercept, -1, 0, by finding the zeros of the real zeros of the top, real zeros of the denominator. We find the X-intercept. Okay, so now Y-intercept. To find Y-intercept, you want to make x equal to 0. So basically you want to look for what is R of 0. So plug in 0 for x, 0 plus 1 over 0 times 0 plus 4. Top is 1, the bottom is 0. 1 divided by 0 is, 1 divided by 0 is what? Is it 0? It's undefined, right? So what does it mean? It means we don't have a Y-intercept. So no Y-intercept. Okay, now finding x, finding y. What else did the textbook find? Domain. Well, the domain, we look at the denominator, right? So x cannot be equal to 0. X cannot be equal to -4, right, from the denominator. So the domain is all the x's except for 0 or -4. Okay. Any questions so far? Finding the domain, X-intercept, Y-intercept?
No.
Okay, now we want to find the asymptotes. All right, so let's check if everything is in lowest terms. This is in lowest terms because we can't cancel out any factors. So the vertical asymptote So we talked about how to find vertical asymptote in 4.4. You look at the denominator, right? The zeros of the denominator will give you the vertical asymptote. So for the denominator, we have 2 zeros. One is x equals 0, one is x equals -4. And they're both vertical asymptotes. And we also talk about the multiplicity will decide, multiplicity. Right? Will decide the behavior of your graph around the vertical asymptote. So here is 1, and the other is also 1 because both factors only appear in the denominator once. Okay, so that means on the two sides of the vertical asymptote, one is going down, one is going up, right? Because the multiplicity of the vertical asymptote is odd, All right, any questions so far? All right. So now found the vertical asymptote. Now next, horizontal asymptote or oblique. Right, we can only have at most one of these two. All right, so let's look at the degree of the denominator and the numerator. So for the denominator, for the numerator, the degree is, what is the degree of the numerator? Degree of the numerator.
1.
1, right? And the degree of the polynomial at the bottom will be what?
1.
It's a 1?
2.
2.
Oh, 2, because you square it.
Because if you distribute this x, you have x squared plus 4x. So degree at the bottom is 2. So the degree of the top is less than degree of the bottom. Which case is it? What kind of asymptote we have? Horizontal or oblique or none? Which case is it?
It's a horizontal.
Yes, the horizontal asymptote. Which one is it? What is the equation? So since it's horizontal, it will be y equals something. What is the equation of the horizontal asymptote? So the degree of the bottom is greater than the degree of the top. It's y equals 0, right? Questions here?
Okay, so it's always 100%. If the degree on the bottom is 1 more than the degree on top, it's always 0.
Not only one more, as long as it's the bottom is more than the top, then it's y equals 0. When they're equal, it's the ratio of the leading coefficient. Right?
Okay.
When the top is more than the bottom, 1 more than the bottom, then you have oblique. 2 more than the bottom, 2 or more than the bottom, then it's no horizontal or oblique asymptote, right? Okay. All right. So now we all want to see also another question from the textbook is asking, will our graph R of X intersect your horizontal or oblique asymptote? So will, in this case, y equals 0. Will the graph cross your horizontal asymptote? How do we find out? We want to know y equals x plus 1 over x plus 4. This graph will have a common point with this graph, right? So to find if the two graphs will cross, you want to solve this system for x and for y. If there's a solution, then they intercept. If there's no solution, then they don't intercept. Okay, so how do we solve this system? Over here, we can solve it by using substitution. I'm going to substitute y in the first equation with 0. Basically, substitute the second equation into the first equation. I will get 0 equals x plus 1 over x times x plus 4. Any questions on what I'm doing right here on this step? Any questions on this?
No.
Okay.
Well, why would it? Is the question in the textbook asking if it'll cross the asymptotes? Because
Yes. The question in your homework. In this case, it's pretty obvious, right? It's the it's just the X-intercept, but I'm just here to answer this in general. Will the R of X intercept y equals 0, or your horizontal asymptote, just in general, how to do it? Am I making sense?
But wouldn't it never cross the asymptote? Because that's the whole point of the asymptote.
No, the well, for vertical asymptote, yes, you will never cross a vertical asymptote. But for a horizontal asymptote or oblique asymptote, it's possible that somewhere it's crossing it, but when x goes to infinity, it will never cross it. So,
Okay.
right, but for vertical asymptote, you can't cross it and then goes to infinity. Otherwise, you know, you won't pass the vertical line test. I don't know if I'm making sense.
Right.
Okay. But it is possible for a horizontal or oblique asymptote to cross your graph somewhere. Okay, for our problem, all right, you want to find if these two graphs have anything in common. This equals 0 if and only if the top is equal to 0, right? So you will actually, your graph will cross the y equals your horizontal asymptote by -1 is 0. This is not a new information for us because y equals 0 is just x-intercept, x-axis, right? So we already found that earlier. We have one x-intercept, right? Okay, anyway, I think we gathered enough information. We can start graphing. Right. So let me start my graph. Okay, so first of all, I have one x-intercept, which is at -1, 0. Just mark it over here. So I have one x-intercept, and then no y-intercept. And now vertical asymptote, I have two. One is at x equals 0. So it's right here. X equals 0. Well, you can tell it's right here. The other one is x equals -4. -2, -3, -4. The other one is right here. Right, and I have a horizontal asymptote, which is y equals 0. Line, y equals 0. Okay, and it shows the graph will cross at y equals 0 and -1. Okay, so let's start graphing. All right, so over here, it's kind of hard for me to decide which way I'm going other than our graph is crossing -1. So I'm going to need a little bit help here. I want to know when x is equal to -2, where is my graph? So I can decide, you know, is it going up or going down from, is it going up or going down from there? Okay. So when my x equals -2, let me plug it in. It's just a point for me to decide my graph, an extra point. So if I plug in -2 in the graph, I have -2 plus 1 over -2 times -2 plus 4. So on top, I have -1. At the bottom, I have -2 times 2, which is, everything is 1 over 4. Right. So when x is -2, my y is 1 over 4. So I know this, my graph will cross this point. Okay. So now that I know my graph will go this way, okay. So we'll keep going up because it won't go down because my graph won't cross the x-axis again, right? So from here we'll go up and all the way up, okay, like along the vertical asymptote. Okay, now on the right side of this x-axis, my graph will cross this -1. The reason for that is the multiplicity for this x-intercept is, you can tell from here, it is odd. It is equal to 1, right? Multiplicity is 1. So this is the same as how we graph polynomials. When the multiplicity is 1, or odd, your graph will cross that x-intercept. When it's even, it will only touch the x-intercept, right? So in our case, since it's odd, it will cross it. It won't go up again, so that means my graph will like this, and it will go down along this vertical asymptote. Any questions so far? No? Okay, so now the multiplicity for x equals 0 is odd, right? That means on the left side and the right side of the vertical asymptote, the graph will go to different directions. So since on the left side this is going down, on the right side your graph is going up. And since your graph won't cross the x-axis anymore, as x goes into infinity, it will get closer and closer to y equals 0. Okay. Now over here on this side of the vertical asymptote, x equals -4. Since once on the right side is going up, that means on the left side it will go down, because the multiplicity of this vertical asymptote is odd, right? And as x goes to -infinity, your graph is going to getting closer and closer to y equals 0, like that. And this is your graph. Any questions on the graph of this rational function?
I get everything up to the where you put the points in and did that.
Mm-hmm.
And then when you added the
-2?
part to the right, because of how it's odd. But then when you did the part on the left, so this graph has like 3 different
Parts, correct.
parts. Yeah, so that part confuses me, just that last part there.
Okay, so you got, let me use another color. So let me see. So you're saying you get this point, right? And you
Right.
get how I got this point. I just need
Right.
a random point to decide.
And I
Okay,
understand that line of how they
go up
Mhm.
all the way here.
Yep.
Okay, so and you also understand
And
why
down.
this is going down.
Mhm.
Okay, so now since your domain is all real numbers but 0 or -4, your graph should appear anywhere but these 2 lines. Am I making sense?
Uh-huh.
So it looks like your graph will be in 3 parts.
Oh, now I get it. So basically you're continuing on the x-axis, but on the other side of
Yes. So
the vertical.
yes. So
And then it just goes to infinity, and then it goes on the other side of the -4 vertical and goes to infinity. But the y is already infinity the way it is, so okay. It makes sense now.
Okay. Any other questions on this problem? Okay. So now let's look at another problem. Moving up. We'll look at, what is the other equation? I just said number 9. So r of x equals 3x plus 3 over 2x plus 4. Okay. So I want to graph this one. This time let's do the domain first. Domain. So the domain of a rational function, you only look at the denominator. What is making the denominator 0 is not in the domain. So what's making denominator equal to 0? 2x plus 4 equal to 0. You get 2x equals negative 4, x equals negative 2. Right, so negative 2 is making the denominator 0. That means your domain is all real numbers but negative 2. Right, so first of all, that's your domain. Okay, so now we want to find the x and y-intercept and all the asymptotes. So now let's factor. It looks like, you know, the top is factorable, the bottom is factorable. So let's factor the top, see if we can cancel out anything. So factor the top between 3x and 3. There's a common factor of 3. I'm going to factor it out. Okay, factor out the 3, I have x plus 1. So for the bottom, common factor is 2. Factor that out. X plus 2. All right. So can I cancel out any factors here? It seems like this is in lowest terms, because you can't cancel out any factors. So in lowest terms. Okay. Now let's look at the X-intercept. So for X-intercept, you need to make y equal to 0, but for a rational function, the whole y is equal to 0 if and only if the numerator or the top of the fraction is equal to 0, right? So we only look at the top. Well, when will the top be equal to 0? When x equals negative 1, right? So the multiplicity of this X-intercept, let me put multiplicity here. Multiplicity is what? 1, right? Because that factor only appeared once on top. Okay, so I have an X-intercept, negative 1, 0. The multiplicity of that is 1. That means my graph will cross this X-intercept, right, instead of touching it. Okay, X-intercept. How about Y-intercept? To find Y-intercept, we make x equal to 0. So R of 0 in this case. We have 3 times 0 plus 3 over 2 times 0 plus 4. That gives us 3 on top, 4 at the bottom. Right, so we have one Y-intercept, which is 0, 3 over 4. Okay, so found the X-intercept, Y-intercept. Now let's look at the asymptotes. Okay, this case is, asymptotes are pretty, well, at least for the vertical. For the vertical asymptote, I would just use VA. What is the vertical asymptote?
X equals negative 2.
Very good. So we only have one vertical asymptote, right? In this case, it's x equals negative 2. What is the multiplicity for that?
1.
1, right? So that means on the left side and the right side of the vertical asymptote, the graph will go to different directions, right? If one side is going up, the other side will go down. Okay. Now, next, horizontal asymptote or oblique asymptote. Okay, we look at the degrees of the top and the bottom, right? So the degree of the top is, degree of the top is?
1.
1. Degree of the bottom is?
1.
1. Okay, since the degree of the top is equal to the degree of the bottom, what kind of asymptote we have? Horizontal or oblique?
Horizontal.
Horizontal asymptote, what is the equation?
That's where you just do the numbers, so it's 3 over 2.
Very good. Y equals 3 over 2, right? When the degree of the top is equal to the degree of the bottom, it's Y equals the ratio of the leading coefficient, 3 over 2. Okay. Will our graph, will R of X intersect our horizontal asymptote? Y equals 3 over 2. Question. So how do we decide that? We want to put the two equations in a system. So you can choose either one. It's already canceled out. Oh, we'll use this one too. Right. First equation, second equation, 3 over 2. You want to solve the system, right? How do you solve the system? Look like substitution, right? Substitute equation 2 into equation 1. We have 3 over 2 equals 3 over 2. Well, 3x plus 1 times 2 times x plus 2. Right. Solve this system. Cross multiply, right? For proportion equations, it's, you know, this 3 times 2, x plus 2 equals 2 times 3, sorry, 2 times 3, x plus 1. Erase this. X plus 1. So this is 6, x plus 2 equals 6, x plus 1. Distribute. 6x plus 12 equals 6x plus 6. Subtract 6x on both sides. You have 12 equals 6. Right? This equation will never be true, right? So the system has no solution because you're getting something that is not true. False. So therefore, will the R of X intercept Y equals 3 over 2? The answer is no, because this system has no solution. Question so far? Okay. So now we can start graphing. All right. So I will graph over here. Draw a system. So first, let me put my X-intercept, which is -1, 0, which is right here. I have an X-intercept and also have a Y-intercept, which is 3 over 4. Let's say it's right here. I'm saying this is an accurate graph, but okay. I have a Y-intercept. I have a vertical asymptote, which is Y equals -2. Sorry, x equals -2. So it's this vertical asymptote. Okay. And what else do I have? I have a horizontal asymptote, which is y equals 3 over 2. Okay, so 3 over 2 is greater than 3 over 4, right? It's on top, it's right here. Somewhere here. Have a y equals 3 over 2, a horizontal asymptote. Okay, and your graph won't intersect the horizontal asymptote. Okay, so we put our information here. Let's start graphing. So first of all, these two are the 2 points we know, right? The x and y intercept. First of all, we have to we'll have to connect these two. Right? Your graph will cross -1 because the multiplicity for this x-intercept is 1, right? We'll cross it. Well, after we cross it, we'll go down like this. So first of all right, how about over here? So after you pass the y-intercept, your graph will just go to getting closer and closer to the horizontal asymptote. Like that, right? Okay, so that's the right part. What about the left part of this vertical asymptote? Since one side, your graph is on the right side is going down, the other side is going up because the multiplicity for this vertical asymptote is 1, which is odd. And your graph won't cross this y equals 3 over 2, the horizontal asymptote anymore. So We'll just get closer and closer to it, like that. So this is your graph. Questions on how I get the graph? You know, or any questions? No? Questions? No questions? We good here? Okay, I'm going to move on.
Yeah.
Okay. Move on to the next problem. Next problem is, what is the next one? Over here. So I wrote, this problem is q of x equals x to the fourth minus 1 over x squared minus 4. Okay, so first of all, let me factor everything. It seems like the top can be factored, the bottom can also be factored. So to factor the top, we can see x to the fourth minus 1 as x squared squared minus 1 squared. So here we have the difference of two squares. So x squared minus 4 is x squared minus 2 squared. Just here doing steps. So on top we'll have x squared plus 1 times x squared minus 1, right? And the bottom is x plus 2 times x minus 2. Here I'm using the formula that a squared minus b squared is equal to a plus b times a minus b. Okay, not done here. This part can still be factored as x plus 1 times x minus 1. So the total form will be over x plus 2 times x minus 2. Okay, so this is the total factored form. Any questions on how I got that? How I factored the top and the bottom?
The thing that I've been wondering about this for a little while. So you go ahead and factor out the second x squared minus 1, but on the first one where it's x squared plus 1, you just leave that?
Yes, because x squared plus a positive number is not factorable.
Oh, okay, got it. Because otherwise it would be plus 2x.
Well, if you have, if you have x squared plus 2x plus 1, that's factored as x plus 1 squared. Okay, so now this is fully factored, the top and the bottom. We can't cancel out anything, right? We don't have any common factors. That means your graph has no holes in it. Okay, now let's look at the domain, first of all. The domain are all the numbers except for 2 or negative 2. Right? So x cannot be negative 2 or positive 2. First of your domain. Now X-Intercept. For X-Intercept, by far we should know you only look at the top. Right? So the top, you have one X-Intercept from here, which is negative 1. Negative 1, right? Negative 1, 0. The other one coming from here, this factor 1, 0. So you may ask, how about from here, x squared plus 1? Will I have any x-intercept from there? The answer is no, because x squared plus 1 can never be equal to 0. This is a number that is always at least 1, right? Because x squared is always positive or 0. So that part will not give you an x-intercept. So we have two x-intercept here. Positive and negative 1. And the multiplicity for each are both 1, right? Because both appeared once in the numerator. Questions so far? Okay, so now Y-intercept. How do we find Y-intercept? You want to make your x equal to 0? All right, so what do I have? I have 0. Let me just plug into the original one, okay? So plugging into the original one, I have 0 to the 4th minus 1 over 0 squared minus 4. It's easier to calculate. So -1 over -4, which is 1 over 4. So your Y-intercept is 0, 1 over 4. Okay. So now asymptotes. Vertical asymptote looks like, how many vertical asymptotes we have and what they are? What are they? What are the vertical asymptotes?
-2 and 2. Oh wait. Yeah, -2 and 2.
But we call it x equals.
Oh, x
negative
equals -2 and x equals
2. Okay. All right. So the multiplicity for each is 1, right? Or they're both with multiplicity of 1. Okay. Now horizontal asymptote or oblique asymptote. So we look at the degrees on top. The degree on top is
4.
4, right? Okay, so degree of 4. The bottom is of degree
2.
2. Okay, so the degree of the top is 2 more than degree of the bottom. So what is the rule?
Then it's not a horizontal or an oblique.
So no horizontal or oblique asymptote, right? And we say the and behavior assembles the ratio of the two leading terms. So the and behavior assembles y equals what? Well, it's the leading term. On top, the leading term is x to the 4th. The bottom, the leading term is x squared. So in this case, it's x squared. All right, so that means your and behavior will be something like that, right? Because y equals x squared goes like this. So your and behavior should be the same as that. All right, any questions so far before we graph? Okay, now let's graph. So first, let me draw the coordinate plane. X-axis, y-axis. Now, what do I have? First, I have two intercepts, sorry. -1 and 1. Okay, so my graph crossed these two. I have one y-intercept, which is 1/4. Let's say it's here. 1/4, okay. And what else do I know? My two vertical asymptotes. One is at -2. Use this color. So x equals -2. I have a vertical asymptote at x equals 2. There is another vertical asymptote. And also, what else? Horizontal or oblique? No. But I know my and behavior will be something like that. Right. Okay. All right. Now let's start graphing. I think we gathered enough information to graph. So first I need to connect these two. So am I crossing the x-axis on both x-intercepts? Yes, because the multiplicity for each is odd. I'm going to do this. Right. We'll go down because we have a vertical asymptote on both ends. Okay, so first is this part. So now we're going to look at this around this vertical asymptote x equals -2. Since one side is going down, the other side needs to go up because the multiplicity for it is odd. Right? So the other side is going up like that. Okay, so am I going to cross the x-axis again? Do I go up and go down and cross x-axis again?
No.
No, because we only have 2 x-intercepts, right? We already graphed them on the graph. So your graph won't cross x-axis again. So somewhere you have to go up. We don't know what this turning point here is. In calculus, in a calculus class, you will calculate where the graph turns. But right now, we just know somehow your graph needs to go up like this. And also remember your end behavior goes like that. So kind of tells you, okay. Your end behavior, according to your end behavior, you should go like that.
Yeah, I wondered about that because the other graph is going down. And so I thought the end behavior would show that it's going up, you know. And so you're looking for the end behavior.
End behavior goes like this, right?
On the side of it then, the one that you did up on top.
On the very left or on the very, very right.
Okay.
So when x goes to negative infinity or x goes to infinity, that's what your end behaviors are, right? Okay. So on the other side of this vertical asymptote, your graph needs to go up because on the left side is going down, right? The multiplicity of that is odd. You have to go to different sides. And because of the end behavior and because we don't have x-intercepts anymore, your graph will somewhere go up again. So this is your graph. Questions?
Would there be another asymptote, like an oblique asymptote for
No.
x?
It's not going to be an oblique asymptote. Your graph is going to behave, the end behavior is going to be same as y equals x squared. So if you look at y equals x squared, it's not closing to a line. It's like a U-shaped. It's not closer to any lines. I don't know if you know what I'm saying.
But then wouldn't the oblique asymptote be y equals x squared then?
Well, that's not, asymptote is a line, right? Asymptote is a straight line. Y equals x squared is a curve, basically. So yes, you can say that. You can say that, but it's not like not touching it, you know, getting closer and closer to it. It's just the end behavior will be similar to y equals x squared. I don't know if I'm making sense here.
Okay.
Okay. All right, any other questions on this problem?
Just one. So since the y would have to go to infinity both ways, it looks like here. So then on those other 2 graphs that are to the right of the one that's in the middle going downwards, then as they would kind of come down, they would have to come at least to the 1/4 at some point and then go back up. Otherwise, it wouldn't be covering all of the numbers, right?
The reason we decide it's going down because, well,
no, not that part. I mean the others. I mean, like, you know how before you said that that they would just come down and then come back up
because
at some
one
point.
side is going down, the other side needs
not
to go
that
up.
one. Yeah, that one there.
This one.
So those ones on the right and the far left. So as each of them start going down, they would have to go at least to the 1.4 and then go back up again, right?
1.4.
I mean, not 1.4, 1/4, 1/4.
1/4? No. We don't know where the graph turns. Is your question? So it will go at least over here, 1/4. We right at this moment, we don't know where the graph turns. We haven't calculated where the graph should, but we know somehow your graph will turn before it touches at the x-axis because you only have two x-intercepts.
Okay, so then that means those top graphs that not really knowing could go
You don't know
all
where
the way
exactly.
up to the x. They could go past the 1/4 then.
It could. It
But
could
they would
be
have
like
to go
this.
at least up to the 1/4. Otherwise, the y wouldn't be infinity.
No, I think it's what she's saying, because if the vertex of the left and the right one don't go below 1/4, that would mean there's a horizontal asymptote, right?
Right.
There's no
So it has
horizontal.
to go at least to the 1/4.
There's no
Or
horizontal.
possibly below it.
Because your graph, as x goes to infinity, it won't get closer and closer to a line. So like as x goes to infinity, it's not like you don't have this case for this problem. So you don't discuss the case with horizontal. You have no horizontal or oblique asymptote.
Mhm.
So it is possible for a graph to have a vertical asymptote of y-intercept of 1/4, but the graph is going below 1/4, but it won't touch the x-axis.
Got it.
Am I making sense here?
Uh-huh.
It is possible. I'm not sure for this. What am I doing? So I erased something important like this. So in our case, we don't know where our graph will go back up, but what we know is it won't touch the x-axis. It will go back up before it touches the x-axis. From the information we know.
Mhm.
Did I answer your question?
Yeah, pretty much. Yeah.
Okay. This for this graph, there's no horizontal asymptote or oblique asymptote. Okay. Moving on to the next problem. Any questions on this problem before I move on?
Nope.
Okay. So next problem. Okay. So let's look at this equation. Which one is it? I did number 14, number 15. Okay, this one. So h of x equals x cubed minus 1 over x squared minus 9. Okay, so it seems like we can factor the top and the bottom. Let's do that first. Okay. So factor the top. X cubed minus 1. I don't know if you remember this formula, but there is a formula. It's the difference of cubes. A cubed minus b cubed equals a minus b times a squared plus ab plus b squared. It's a formula, right? So x cubed minus 1 satisfies that situation because it's x cubed minus 1 cubed. So we're going to use the formula to factor the top as x minus 1 times x squared plus x plus 1. Just basically using the formula. That's the top. The bottom is x squared minus 3 squared, so it's x plus 3, x minus 3. Any questions on the factoring part? All right. So now, first we look at the domain. So for domain, you only look at the denominator, right? So x cannot be 3 or negative 3. Negative 3 or x cannot be 3. All right. Now, x-intercept. So for x-intercept here, we look at the numerator, right? The zeros of the numerator will be the x-intercept. So 1 is pretty obvious coming from here, which is 1. So 1, 0 is 1 x-intercept. Will we get any x-intercept from here? No, but we can do some calculation and see why not. X squared plus x plus 1 equals 0. You want to solve for this? How do we solve it? Well, here we can use the, negative b over negative b plus or minus square root of b squared minus 4ac. Try to solve it, see what will happen. So b is 1, negative 1 plus or minus square root of b squared is 1 squared. 1 minus 4 times your a is 1 times your c is 1 over 2 times 1. It's pretty obvious underneath the square root, it's a negative number. So this means no real solutions, right? So you won't have any x-intercept coming from that part, x squared plus x plus 1. So you only have one x-intercept, which is 1, 0, and the multiplicity for that is 1. It only appeared once. All right, so now y-intercept. To find y-intercept, we want to make x equal to 0. So h of 0 will give you 0 minus 1 over, I'm plugging into the original one, 0 minus 9. That's positive 1 over 9. So we have one y-intercept. 0, 1 over 9. Okay, now vertical asymptote. Right, so including the multiplicity. So we have how many vertical asymptote and what they are? There's one is x equals, what are the vertical asymptotes?
Oh, the vertical, -3.
-3, and the other one is
and
x
3.
3. Right? The multiplicity for each is
1.
1 and 1. Okay, good. Now let's decide if there's any horizontal or oblique asymptote. So how do we decide on that? Look at the degrees of the top and the bottom. So degree on top, the top has a degree of
3.
3. The bottom is of degree
2.
2. Okay, the degree of the top is 1 more than the degree of the bottom. What does it tell us? What kind of asymptote we have?
Oblique.
Oblique asymptote. Right? We'll have an oblique asymptote. So we decide what is the oblique asymptote by using long division. Okay. So long division. So inside we should have x cubed minus 1. But here we like to write down all the terms, all the missing terms. So after x cubed, there will be x squared. That's 0x squared. Then you have 0x, and then we'll go to minus 1. And on the outside, x squared minus 9 is actually x squared plus 0x minus 9. Any questions so far?
No.
No? Okay. So now let's do the division. Since we have 1, 2, 3 terms to divide, the first term will appear on top of this 1, 2, 3, on top of here. Okay. So we need a term so that this term times x will give us x cubed. So that term would be what? What times x? X times x squared is x cubed. So x. Keep going. X times 0, it's 0. Right. X times negative 9 is negative 9x. Draw a line. Subtract. Right. So x cubed minus x cubed is 0. 0 minus 0 is 0. Last over here. 0 minus 9x. Sorry, 0 minus negative 9x is positive 9x. Correct?
Yep.
All right, so now bring down the next term, -1. Okay, so here, this is not, you cannot divide this 9x minus 1 by x squared plus x minus 9 anymore, because the degree of 9x minus 1 is lower than that. So you're pretty much done. This is the remainder. But the remainder doesn't help us. What we want is here. Right? This gives you the oblique asymptote, which is y equals x. So y equals x is your oblique asymptote. Y equals the quotient, right, is the oblique asymptote. Any questions so far on how I got the oblique asymptote?
No.
Okay. No, okay. So now, what's the next? I want to decide if my graph will intersect y equals x, will intersect the oblique asymptote, right? So I will ask myself this question: will h of x intersect the oblique asymptote, in this case y equals x, question mark? Well, how do we decide that? We want to see if y equals x cubed minus 1 over x squared minus 9 have any common point with y equals x. And we want to solve the system. So how do we solve the system? Here's by substitution, right? You want to sub your y in the first equation with x. So you have x equals x cubed minus 1 over x squared minus 9. How do we solve this equation? You can see this as fraction equals another fraction. So cross multiply. We'll have x times x squared minus 9 equals x cubed minus 1. Distribute. X cubed minus 9x equals x cubed minus 1. Well, it looks like we have a solution. Cancel the x cubed. You have negative 9x equal to negative 1. Divide both sides by negative 9. Right, one solution is 1 over 9. Okay, so we want a point. We want to know where the graph will intersect y equals x. Well, the x coordinate where it intersects is 1 over 9. What is the y coordinate? Well, how do we find the y coordinate? You know your x is 1 over 9. You want to plug it back into the system, right? The easiest way is to plug into here. You got y equals also 1 over 9. So will your graph intersect y equals x?
I'm confused. I don't know. Maybe I'm just not seeing it right. Like back, what I was thinking it was x is negative 1 over 9.
Is it? Let me see. No. Negative 1 over 9. So you understand this part? Negative 9x.
Yeah. So if you add 9 to each,
divide
and then it's x equals negative 1 over.
Divide negative 9 on both, right? So negative 1 over negative 9 is positive 1 over 9.
But it's
Negative divided by negative is positive.
I added a
Not
positive
add.
9 under each.
Not add, divide.
Oh, divide. Okay.
Because negative 9 is multiplied to x, not.
Okay, got it. All right, I was making a mistake there. Okay.
So therefore, our graph will intersect y equals x at 1 over 9, 1 over 9. Any questions on that part? Okay, it seems like we gathered enough information. Let's graph. So coordinate plane, x, y. So I have one x-intercept, which is 1, 0, right here. And a y-intercept, 1 over 9, 0. So it's, let me just roughly mark it here. This is 1 over 9 on y. Okay, I have two vertical asymptote. One is x equals -3, so -1, -2, -3. We have a vertical asymptote, x equals -3. Another vertical asymptote, x equals 3. All right, what else? We have an oblique asymptote. Oh, this graph is a little bit, let me make it smaller. So we have an oblique asymptote, which is y equals x. So y equals x, it's a line, right? How do you graph it? First, y-intercept, 0, and the slope is 1/1. It's like 45-degree angle. So let me just use dotted line. Okay. So it's kind of like this. All right. So gathered all the information. 1/9. So our graph will intersect the graph at 1/9, 1/9, 1/9. It's kind of right here, right? This is where our graph will intersect the y equals x. Okay. All right, so let's start working. So it looks like, you know, my graph is going to do this first. Okay, now my graph is going to cross this x-axis. The reason for that is the multiplicity for this x-intercept is odd, right? So my graph is going to cross it. And then directly go down like this. Okay, so since the multiplicity for this x equals 3, this vertical asymptote is odd, that means since once the left side is going down, the other side is going up like this. All right, since my graph is not crossing y equals x, the oblique asymptote anymore, other than 1/9, 1/9. That means my graph is getting closer and closer to this line and never cross it after. You know, from there on, it's like this. Okay. All right. So now for the other side, is my graph going to go up or go down from 1/9, the y-axis? I think it's going up because it won't cross the x-axis anymore when we have one x-intercept. So somehow it needs to go up. So the graph will look like this. All right, since the multiplicity for x equals -3 is odd, and on your right side is going up, on the left side needs to go down like this, right? And your graph won't cross the y equals x anymore, so it needs to get closer and closer to that line as x goes to -infinity. So this will be our graph. Questions?
No?
No? Okay, awesome. Okay, the next problem I want to go over is 15, 17. You know what? I want to skip 17. Let me do 32. This one. Okay. 29. Okay, let me do 32. So 32. I'm talking about the textbook. R of x equals x minus 1 times x plus 2 times x minus 3 over x times x minus 4 squared. Okay. I want to graph this function. Okay, now, since it's already factored, and we don't have to factor this, what domain? What is the domain here? Well, we look at the denominator, right? What x cannot be equal to x? First of all, cannot be equal to 0. And also, it cannot be equal to 4. So your domain needs to exclude those two numbers. Okay, now, X-intercept. So for X-intercept, you look at the top. So we have, just make 3 X-intercept, looks like. One is 1, the 1, 0. What is the other one?
Negative 2 and then 3.
Very good. So the other two are negative 2, 0 and 3, 0. The multiplicity for each are all 1s. Right? All right, now Y-intercept. So what is the Y-intercept? We make x equal to 0, do the calculation. I don't know about the top, but it looks like the bottom is 0, right? Since the bottom, whatever the top is, since the bottom is 0, that means this number isn't defined. So no Y-intercept. So none, because the bottom is a 0. Okay, so now asymptotes. First, vertical asymptote. How many vertical asymptotes we have here? The first one is, or one of them is
X equals 0.
X equals 0, and the other one is
X equals 4.
X equals 4. So finally, the first multiplicity is 1, right? X equals 4. The multiplicity for that is also 1.
2.
2, right? Okay. So that means on the left side and the right side of the vertical asymptote, either your graph are both going up or both going down. Right? They're going toward the same direction. All right, now what else do we need? A horizontal or oblique asymptote. So how do we decide on the horizontal and oblique asymptote? We look at the degrees. Right? Degrees on top is
3.
3. Degree at the bottom is
3.
3. Okay, so that means what kind of
Horizontal.
horizontal, and the equation is y equals. So since the degrees are equal, the
Y equals 0.
is it 0?
Would it be 1?
1, right? We look at the ratio of the leading coefficient. So the coefficient, leading coefficient on top, you can tell if you distribute, you will have like x cubed plus blah, 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 right? At the bottom, you will also have x cubed, blah, blah, blah. This is the first term, leading term. And the leading coefficient here is 1. The leading coefficient at the bottom is also 1. 1 over 1 is 1. That's the horizontal asymptote, the ratio of the leading coefficient. Okay. Now, will our graph, r of x, intersect the horizontal or oblique? Well, and this is horizontal asymptote y equals 1.
Could I ask a question that goes back further? I understand everything we've been doing. There's just one thing in the math that's got me confused. Way back to the denominator. I know that x would be 0, but then the x minus 4 squared. I think what I've been doing is I look at that and I've been factoring that to x minus 2 and then x plus 2. So then I thought that, like I would have thought that then the vertical asymptote would be 2 and negative 2 and 0.
I think you are seeing this as, you're confusing that with x squared minus 4. X squared minus 4 and x minus 4 squared are different. Over here, you factor that as x plus 2, x minus 2. At the bottom, there's same factor x minus 4 appeared twice, right? So it's x minus 4 times x minus 4. So
which would be totally different. That would be x, yeah, that would be like x squared minus or plus 16. Okay.
No, this is not x squared minus.
Or wait.
This is x squared minus 8x plus 16. If you FOIL it, you will see. If you just do it, you will see. Anyway, that's why we got the x equals 4 as a vertical asymptote.
Okay.
Okay.
Yeah. Okay. Yeah, I need to work on more of that. I barely had any factoring many, many years ago.
Yeah.
So I had to relearn that recently, and I missed that part there again.
Okay, so how do we decide if the two graphs intersect? We want to see if the original function, r of x, so write it down again, over x times x minus 4 squared. Ooh. Will that be equal to y equals 1? All right, let's try to solve it. All right, so substitute y into the first equation. Looks pretty ugly. Let's see. I don't even want to look at this problem, but let's see. All right, so cross multiply, right? Okay, on top we have x minus 1 times x plus 2 times x minus 3. Then we have equals x times x minus 4 squared. Any shortcut on this? I don't see one. So I have to use the worst way, right? Just to FOIL and multiply. Okay, I'm going to, wait a second. I'm going to multiply these two. X minus 1. Okay, multiply those two. If you FOIL it, like do this, you should have x squared minus x minus 6. For this one, you can use the formula. That's x squared minus 8x plus 16. Keep going. So here you have to really distribute. X cubed. This one will give you negative x squared. This way, negative 6x. Okay, now this way, negative x squared. This way, positive x, and this way is positive 6. Ooh, okay, on the right side, let's distribute x. X cubed minus 8x squared plus 16x. All right. Okay, x cubed and x cubed, they cancel on both sides. On the left side, combine like terms. These two are like terms. Negative 2x squared minus 5x plus 6. On the right side is negative 8x squared plus 16x. All right, move everything to one side. All right, so add 8x squared on both sides. Now let me subtract 16x on both sides so I can move everything to one side in one step. So after I do that, the right side should be equal to 0. The left side is 6x squared minus, what is this? 21x plus 6. Ooh, okay. There's a common factor of, you know what, I'm just going to solve it. I know this is not factorable. I'm just going to go straight solving. 21 plus or minus square root of b squared. And I don't want it to, okay. Let me simplify it. The number is becoming too big. Sorry. So I see a common factor of 3. Let me divide the left side and right side by 3. So I have 2x squared minus 7x plus 2 equals 0. This is pretty obvious to me that this is not factorable. Now let me just solve it by using the formula. 7, that's negative b, plus or minus b squared, 49 minus 4. Oh, there's a solution. Oh no. Times 2 times 2. 4 AC, yes, divided by 2 times 2, 4. Plus or minus. Did I put this problem in the, no, I don't think so. So what do I have? 49 minus, what is this number? 16? Some kind of positive number. 3. My brain is dead. Okay, 33 over 4. Okay. It seems like we have the two graph will intersect twice. One is 7 plus square root of 33 divided by 4, 1. The other one is 7 minus square root of 33 divided by 4, 1. Oh, I wonder what they are. Square root of 33, that's 5 point something. 5.5 maybe. So 7 plus 5 is 12. 12 divided by 4. 3 point something 1. 3 point something 1. And the other one is minus 1.1 divided by 4. That would be 0 point something 1. Not sure what it is, but we're just roughly graphing it. Okay. Let's start graphing. Okay. It's a bad problem. Okay, now, first of all, X-intercepts. 1, negative 2, 3. 1, negative 2, negative 2. Okay, 3. The reason I want to do this problem because we have a multiplicity of 2 here. I didn't know this problem is going to be this complicated. No Y-intercept. Okay, so we have 2 vertical asymptote. One is x equals 0. X equals 0, one vertical asymptote. The other one is x equals 4. Send it a little bit over here. Okay. Now, let me mark this is odd, and the other one is even. Okay. So now what else? We have one horizontal asymptote, which is y equals 1. So it's going to be over here. We have a horizontal asymptote. Y equals 1. And what else? Our graph will intersect this horizontal asymptote y equals 1 at 3 point something, so somewhere here. And the other place is somewhere 0 point something. So we'll intersect the horizontal asymptote at those 2 points. Okay, and no Y-intercept. All right. So right now it's not very clear to me where I should start. Oh, it's pretty clear too. I'm sorry. So first of all, I need to connect these two somehow. All right. So since the multiplicity for all the X-intercept are odd, the graph will cross on all of them. Kind of like this. All right. So, okay. So that's this part. All right. So my graph will cross on this point and it seems like it will go up. Okay. Since the multiplicity for x equals 4 is even, that means on the other side of the y equals 4, this vertical asymptote, it will go up also like this. All right, and then your graph won't cross y equals 1 anymore. We'll just go like that. getting closer and closer to y equals 1. All right, on the left side, it seems like I'm going up because I can't go down. Right? I'm going up here. All right, since I'm going up, the other side needs to go down. Like this. And my graph will cross the y, cross this x-intercept, -2. And my graph is getting closer and closer to y equals 1. So this should be my graph. Rough graph, okay, not a very accurate graph. Any questions on this problem? Yeah, this one is tough on finding will like your graph intercept y equals 1. But any other questions? All right. Okay. So the reason I put this problem there is because I want to show over here when the multiplicity of your vertical asymptote is even on both sides, it will go to the same direction. Right? If one side is going up, that means the other side is also going up. Okay, one more problem. Probably the last problem. Let me pick wisely, either 29 or 44. Let me see. Which one do I want to do? 29 or 44? Let me do another one with vertical asymptote. Sorry, oblique asymptote. Okay. All right, so 29 is the one with the oblique asymptote. Okay, 29. Any questions on the previous problem before I move on to 29? Before I move on to the next problem. Any questions on this one?
Nope.
I know the calculation is crazy, but all right. So last problem, last example. X squared plus x minus 12 over x plus 2. Okay, so this problem. So now, first of all, let's factor. Factor the top and factor the bottom. To factor the top, what should we get if we factor the top?
X plus 4, x minus 3.
Very good, plus 4x minus 3. All right, so the domain here should be all real numbers but 2, -2, sorry. Right. Okay, now for the x-intercept, we look at the numerator, right? The numerator, what numbers will make the numerator equal to 0?
2.
2. Okay, so what numerator? The top. X-intercept here we're talking about.
So -4 and 3.
-4, +3. The multiplicity for each is 1 and 1. That means your graph will cross on those two x-intercept on the axis. All right, y-intercept. So we've done many times with this before. To find y-intercept, you want to make x equal to 0. So plug in to the original, have 0 squared plus 0 minus 12 over 0 plus 2, which is -6. So 0, -6 is your y-intercept. All right, now asymptote, vertical asymptote. What is the vertical asymptote? What is the vertical
X equals -2.
Very good. And the multiplicity here is
1.
1. Okay. All right, now horizontal or oblique. Which one is it?
What do we mean there?
Let's look at the degree. Degree on top is
3.
2.
2, right? Degree at the
Oh,
bottom.
sorry, I was looking
sorry.
at the other
Yeah. The degree at the bottom is
1.
1. Okay, degree of the top is 1, one more. Then the degree of the bottom. That means what kind of asymptote we have?
Oblique.
Oblique, right? So how do we decide what the equation of the oblique asymptote? We use long division, x squared plus x minus 12. We don't have any missing terms. So x plus 2. Since we have 2 terms over here, the first quotient term will appear above this x. Right. So what term should I put here? What should I put here as my first quotient term?
X.
X, right? How do I find that? I need something to multiply x to get x squared. So x times x is x squared, then x times 2, 2x, draw a line, subtract. X squared minus x squared, 0. 1x minus 2x is negative 1x. Right, drop the next term. Right, now I need something over here so that that term times x gives me negative x. So what do I put as my second term of the quotient?
Would it be negative 6?
I need something here so that this times x is negative x.
So
Just 1.
negative,
Negative 1, right?
Uh-huh.
Negative 1. Negative 1 times x is negative x. Negative 1 times 2 is negative 2. Draw a line, we subtract. Okay, so negative x minus negative x, 0. Negative 12 minus negative 2 is negative 10. Right?
Okay.
Okay, so the remainder, we don't care about this for now. The quotient will give us the oblique asymptote, which is y equals x minus 1. Right. All right, so we can start, well, last question. Will your graph f of x intersect your oblique asymptote y equals x minus 1? Well, how do we find that? System. Solve the system of equation. X squared, well, y equals x squared plus x minus 12 over x plus 2. And this is the f of x. The other one is y equals x minus 1. We want to see if these two equations will intersect. All right, so how do I solve it? Substitution. Right. Substitute y in the first equation with x minus 1. So I have x minus 1 equals x squared plus x minus 12 over x plus 2. Okay, to solve this one, doesn't seem that bad. Cross multiply, right? So you have x minus 1 times x plus 2 equals x squared plus x minus 12. Oh, let me expand the right side. So by double distribution or FOIL, right? X squared this way, 2x this way. This one is minus x, and this one is minus 2. All right, simplify. X squared plus x minus 2 equals x squared plus x minus 12. you can see x squared and x squared, they can cancel on both sides. X and x, they will cancel on both sides. On the left side, what's left is -2. On the right side, what's left is -12. This is obviously false, right? So that means the system doesn't have a solution. Will your f of x intersect y equals -1? The answer is no, because that system do not have a solution. All right. I think we gathered enough information to graph. Let's get started. Any questions before I graph? All right, so graph real quick. X, Y. First is the X-intercepts. One is -4, -1, -2, -4. So over here. The other one is +3, 1, 2, 3. So over here. What else do I have? We have a Y-intercept, -6. 1, 2, 3, 4, 5, 6. Say it's here, -6. All right, we have vertical asymptote, x equals -2. Vertical asymptote right here, x equals -2. Multiplicity is odd, so I know how my graph look like. And we have an oblique asymptote, which is y equals x minus 1. So how do I graph y equals -1? X minus 1. First, the y-intercept here is -1, right? And your slope is 1, that means go up 1 over 1. So these 2 points, well, these 2 gives you the oblique asymptote. Goes like that. Y equals x minus 1. Okay, start graphing. So first of all, let's see the points I have. I can connect these two. All right, so after I connect those two, oh, my graph will cross it. Of course, it will cross it. And it seems like it won't go up because my graph won't cross y equals the oblique asymptote. It needs to go down, all the way down. Right. All right, since the multiplicity here is odd, the right side is going down, the left side needs to go up. And somehow I need to go back to this point, the x-intercept, -4. And will it cross it or just touch it and go back up? Will my graph cross the x-axis at -4, or will it just touch -4 and go up? How do we know that? We look at the multiplicity of
it's odd, so it crosses.
crosses, right? So since it crosses and we have this oblique asymptote here, that means my graph is, okay, I didn't draw it very well, but my graph was getting closer and closer to this oblique asymptote, right? All right, on the other side, my graph will cross at this 3 because the multiplicity for this x-intercept is odd, and getting closer and closer to that oblique asymptote. I'm going to be like that. Okay. So that will be my graph. Looks like two straight lines, but they're actually curves. Questions here? All right.
No.
I'm going to call it a day. If you have questions, I will stay here longer and answer them. But if not,
I just have one question from the
Go ahead.
quiz. There was only one I couldn't figure out that I messaged you about. It
Mhm.
was number 6,
Number 6.
and it was just as far as, well, it said R of x equals 18x over x plus 15.
Let me go to number 6 and find out. So you're talking about the quiz from last week?
Yep.
Okay. Could you, I don't know, could you write it down somewhere? Let me see if I can give you a white space. Could you write it down? I think
I-
you use whiteboard, you can write it down on the.
I can write it and then you see it?
Well, I don't know. Do you have the, maybe you don't, okay. Let me,
I'm not sure how to do that. I didn't know we could do that.
okay. So I
But I can
could-
tell you the problem.
Yes,
It's
let me write it.
It's
R,
R of X equals 18X over X plus 15.
okay. So what are they asking you?
Okay, so I understood how to move everything and graph it, but so I thought,
Mhm.
but what I wasn't understanding is, like, if it had said R of X equals 18 plus X over X plus 15, then I would have thought you definitely move the graph up 18
Oh,
spaces. And the graph that they said was correct was as if it said 18 plus X over X plus 15.
so
Because they had it to where the horizontal asymptote was Y equals 18. And I just wasn't understanding that.
so you're
Because I
given,
thought when the number's like right next to the X, that you just multiply it by a factor of 18, which doesn't change it all that much. It just stretches it. So that problem really throws me off.
okay. So I will talk about this in two ways. First is what we talk about today, right? How they are giving you 4 graphs to choose from, right? You want to choose the right one. Is it the problem?
Well, I asked what the horizontal asymptote was, and it asked what the vertical asymptote was, and the oblique asymptote. And
Oblique, so horizontal or oblique, right?
and so I understand that the oblique, I'm sorry, I understood that the vertical asymptote is X equals negative 15. I see that.
Mm-hmm.
And I could tell that there was, I didn't think there was any oblique because of how it's X over X. So then it makes it that it would have to be a horizontal. And so I understood that.
So
But
why
then I thought it would be
you don't understand why the horizontal
like
asymptote
why
equals
why is it
y equals 18?
yeah, for the horizontal, because I never imagined moving it up to 18.
So the degree of the top is 1, right? Degree of the bottom will also be
1.
1. Since the degree of the top is equal to the degree of the bottom, that means you have an horizontal asymptote, right? So first you decide that. So what is the equation of the horizontal asymptote?
So then that would be 18 over 1, which is 18. So that's why it's y over equals 18. Okay, for some reason I was thinking something different when I did the quiz. And I thought that if the horizontal asymptote is where y is equal to 18, I thought that means that the entire graph moves up to that where it doesn't touch it. And when I looked at the problem, just looking at it, I thought then it would have to word it like R of X equals 18 plus X over X plus 15. And I just wasn't seeing it. But now doing it this way, it makes sense.
Okay. Any other questions?
Yeah. Okay. But I wonder then if it did say 18 plus X over X plus 15, it would be totally a different graph.
Well,
then, huh?
no, it's, so
then it would be with a 0 asymptote.
No, if you want to graph it by using, so I haven't mentioned it. I said I will use 2 ways. Another way is you want to graph it by using transformation. So this, let me write this again. I'm going to do some algebra changes. So 18, I'm going to do this real quick. It might be confusing, but what I did is just add a 0. Okay, so I will have, what's 18 times 15? It's a number. Let me just use calculators real quick. What is
Yeah, I have to look. 18 times
18 times 15?
15,
What is it?
270.
270. Okay, this number is not very important, but I'm going to do it this way. So do you agree that I can write this as,
Mm-hmm.
okay, so this will just give you an 18, right?
Okay.
Okay, so we can graph this function by using transformation from the function 1 over x, right? First, you can change it to 1 over x plus 5, right? By moving your graph 5 units to the left. So 5 units left.
Yeah.
So here is like that, right? 5 units left becomes like this, first of all. It's an ugly graph, but something like that. And then multiplying to a 272 is just stretch it. It doesn't change the look too much. And then you add a negative sign to the whole thing. Right? So that means your graph is upside down. So before it was, you have this, so it goes like this, right? Okay, question so far? Okay, now I want to turn that function into 18 minus turning into, you know, our R of x. So you're adding an 18 to the whole thing, basically. So adding 18 to the whole thing, meaning moving your graph 18 units up.
Mm-hmm.
Right? So your graph becomes, so before you have the horizontal asymptote with y equals 0, now it's 18 units up. So your horizontal asymptote becomes y equals 18. I know it's not proportional here, but.
Okay. Yeah, I think I just got used to some that we had before previously, where
Yeah.
all you had to do was look at the equation
Without changing.
and you could just tell how many up it had to go and how many down or how many to the left or how many to the right. And so I didn't actually,
so this one, if you want to graph it by using transformation, you have to change it to the form that you can see it as, you know, transformation.
So that, yeah, that's what I had done. I just didn't see that it was moving it at 18 because of how it was right next to the X. And
yeah.
But when you actually do it and see that, then it is y is 18. So
yeah.
Okay.
Okay. Any other questions?
That's it.
All right.
Thank you.
Have a nice day.
You too.
All right. Questions? Okay, if not, I'm going to call it a day. Right?